Well, thanks for coming out, and welcome. My name's Glenn Field. I'm what's called the Warning Coordination Meteorologist out at the National Weather Service in Norton, Massachusetts, home of the tornado from 2 days ago. Seriously, just 1 mile from our office. Pretty incredible. I did the storm survey yesterday, and very localized damage. Very lucky that it happened in a fairly wooded area. But anyway, so I work for NOAA, the National Oceanic and Atmospheric Administration, National Weather Service, and your government tax dollars paid for this presentation. All right, so what I wanted to talk about today, I actually have 2 different presentations. I'm not sure what was advertised, but one of them is kind of my favorite, is severe thunderstorms and tornadoes. And we do get them around here, as we just found out a few days ago. The other one is called the realities of New England hurricanes. And we get them too, but we haven't had one in an awful long time. So it's good that you're here to prepare for what could happen someday and will happen someday. So we'll take you through the realities. Now, can we hit these lights a little bit? Is that going to mess up?
Just be careful, because I need the light up there to see you.
Maybe just a little. Can we dim anything in the front? Just the. Yeah, let's see. Sorry, I should have done this before we started. You can edit. Need a dimmer. Oh, that's perfect. Yeah, that's good. How's that? That's perfect. And that'll work. Okay. So, whoops. Sorry about that. Okay. So I can stand over here because I can click. So this is our first presentation called Severe Thunderstorms and Tornadoes. Okay. Some of the jokes are corny, so you have to be prepared to be annoyed. But I'm just warning you now. This is New England. We don't get tornadoes, right? That's what everybody says. So I like to call it the 5 stages of weather denial. The first stage is that never happens here. Didn't happen in October of all things. October 3rd, 1979, an EF4 tornado destroyed the Bradley Air Museum in Windsor Locks, Connecticut. The second stage is, well, okay, it happens, but it won't happen to me, right? It didn't happen at the YMCA in downtown Providence, for example, in 1986, because tornadoes don't hit big cities or anything. Stage 3 is, well, maybe it could happen to me, but it won't be too bad. Certainly won't be a moving experience or anything. That was from the Worcester Tornado back in 1953. Stage 4 is fine. Maybe it'll happen, maybe it will be bad, but I'm not going to be able to do anything about it. So why should I waste my time trying to get ready? Because tornadoes don't strike big cities or anything. Like New York City during the Tall Ships Parade in 1976 for the bicentennial. Or at the Mormon Tabernacle in Salt Lake City. Or in downtown Miami, a waterspout that moved on shore. Doesn't happen. Or how about at the Washington, D.C., right outside the Washington Monument, just a couple of days after 9/11. A tornado moved through a week or 2 weeks later, and they're still cleaning up the Pentagon. Okay, so then you hear a roaring sound. Helen Hunt goes flying by. Bill Paxton, for the women in the audience, from Twister. And you realize you don't know the first thing about what to do. That's when you've reached the 5th stage of weather denial, which is holy moly, right? In Ohio, it's Holy Toledo. Cape Cod, it's Holy Mackerel. Anyway, so this is a little bit older slide since we just had a few tornadoes a couple of days ago, but and several of them in Connecticut this year, and we had the Worcester Tornado. I'm tired of tornadoes this season. Fortunately, nobody's been killed by any of them, and they've been on the weak variety. We'll talk about that more in a little bit. But in general, from 1950 through 2017, so that's a pretty substantial period, 68 years altogether, if you count each of the years. We've had 38 tornadoes in Worcester County, so that's about one every year and a half to 2 years. But that's a big county. So if you divide it in half, maybe like 19, which fits with some of the other numbers. In general, Western Mass, Northern Connecticut, and even into Southeast New Hampshire is a little mini tornado alley in our area. Not as much down here, but we have had a few. Let's say 8 in Bristol County over the 60-something year period. So about once every 8 years or so. But that's because of the cooling effect of the ocean down here. Usually storms die out when they get this far to the east, assuming they're coming from the west. So the point is we do get them. This is an old slide, but I left it in there because it illustrates a long time ago I had said in Worcester County we get 34 in the last 51 years. So like I said, it's an old slide. But the last one on the list had been in 1990, and sure enough, Mother Nature made up for it and had the June 17, 2001 Father's Day tornado, which I'll show you some pictures of here. In Middlesex County, they get one every 3 years, and the last one on the list was 1986. And sure enough, at 3 o'clock in the morning, we had a tornado in Concord, Massachusetts, just a couple of years ago. And we know about Hampden County, right? Hampden County had one every 3 years. The last one on the list was 1992, and what happened? The really big one on June 1st, 2011 in Springfield and Munson, and we're going to show you pictures of that. So Mother Nature has a way of making up for things. Now, taken as a percentage of all tornadoes, actually Connecticut ranks number 2 in the country in terms of violent tornadoes. So granted, you're dividing by a smaller number because it's not the Midwest and we don't have that many. But it's interesting to look at it that way. Massachusetts is 1.6% of all tornadoes that are the violent kind, the EF4s and the EF5 tornadoes. And Connecticut is 4. The national average is 1. So all of New England is above the national average in terms of violent ones. So we don't get them very often, but when they do, they can be violent. So let's take a look at some of those. In Worcester in 1953, that was the granddaddy of them all. 94 people killed, over 1,200 people injured in an EF4 tornado. Back then, there was a truck stop tornado in West Stockbridge out in the Berkshires in 1973 that killed 4 people, EF4. The Windsor Locks that I mentioned in October of 79 killed 3 people, injured 500 people. And more recently, we had Great Barrington in 1995, which I'll show you in this presentation. That was ranked the EF4 tornado, and I actually went on that storm survey. And then the last really big one here was in Springfield and Munson back on June 1st of 2011. Killed 3 people, injured 200 people. So switching gears, talk about lightning a little bit. Lightning is deadly, and there was a study done in the Northeast here that showed where the injuries and fatalities occurred. And so 50% of the locations weren't documented, but of the other 50%, what's the number one place that people get injured? And it wasn't under trees. It was in open fields, ballparks, and playgrounds. Okay, because you're the tallest object around. And under trees was number 2, and being on the water, in the pool, or swimming, boating, fishing, that's not safe too. Water conducts electricity. Golfing is high on the list. But talking on the telephone is only 1.6%, so we tell our spotters, get out there and give us a phone call. I'm just kidding. Just kidding. Wait until the storm is safely passed, right, to give us that report. Same thing with radio transmitters, our amateur radio operators, only 0.5%. But stay away from those rigs indoors. Typical summer day, cumulus clouds form, and the atmosphere heats up and just boils it up. Thank you. The next slide is what happens after they boil up. It turns into not just a cumulus cloud, but a cumulonimbus cloud. Cumulo meaning it's very puffy, and nimbus meaning rain is coming out of it. But that's another name for a thunderstorm. And just a little bit of meteorology here. This is the troposphere where all the weather occurs. This is the very stable stratosphere way up here. And because it's stable, it forces the storm to flatten out at the top. And we call that an anvil, which is roughly at the tropopause level, the interface between the troposphere and the stratosphere. But in the case of a severe thunderstorm, which is what this presentation is about, you have such a strong updraft. Every thunderstorm has an updraft and a downdraft, but the updraft is so strong that it overshoots that anvil level into the stratosphere. And you can see it by just that tower above the anvil level. And if you see that and it persists for 5 or 10 minutes, then there's a 99% chance that that storm is severe, producing large hail, damaging winds. Maybe, never say never, a tornado. There's another one over there. So that's called the overshooting top. Oh, I don't have to walk there, do I? All right, let's talk about thunderstorms and lightning. How hot is a lightning bolt? What do you think? Got an idea? How many degrees?
What?
How many degrees do you think it is? How hot it is?
Like, maybe like 1,000?
That's a good guess. But it's hotter. Much hotter.
A million?
Not that hot. Well, although I've never measured it. This is just what the book says. But 50,000 degrees Celsius. So that's incredible. That's 5 times hotter than the surface of the sun, which is 11,000 degrees. Again, I've never measured it, but it amazes me how you can be struck by lightning and still survive with mouth-to-mouth resuscitation because it travels along the outsides of surfaces. We'll get more to that in a minute. Anyway, lightning likes to strike the tallest objects. There's the Prudential Tower in downtown Boston. And it's doing what it's supposed to do. They put a lightning rod there, and it safely gets grounded down to the ground. The Empire State Building gets struck 30 times in a row sometimes in New York. You ever hear the expression, lightning never strikes twice in the same place? Yes, it does. Because once it digs its path through the atmosphere, it's very easy to come down through the very same channel. But it's not always the tallest objects. There's a space shuttle on the launch pad, but lightning struck the base of the space shuttle. Here's the tallest object in the parking lot, big metal object, the lamppost, but lightning struck 50 feet away. So you can't be too careful. Here's lightning striking a church steeple in downtown Providence. And here's an airliner near Osaka, Japan, just took off from the airport, 46 people on board. And I've been on a plane before where it gets struck and you hear a little pop. But this served as the initiator of the lightning strike, with lightning going both upward and downward from the plane. And it did damage some of the cockpit instrumentation, which is not good when you're flying. And they were able to land safely because they were right at the airport right there, turned around and landed. But ever since then, they had this rule that they take, for safety reasons, a picture in the cockpit every 15 minutes. And we happen to have the very first picture there. This is my little attempt at humor. Okay. You see the planes coming right at him? Okay. So, some of these jokes, I told you they're corny. What's the first thing you should do when you feel that electrical charge? Your hair stands on end to go meet that charge up in the cloud. What should you do? What should you do?
Maybe you should turn your hair upside down so that...
No.
Go inside.
Well, you're up on Morro Rock in Sequoia National Park, California, and there's no place inside.
Low as you can.
What?
Right. Well, the first thing I would say is take a picture. Just kidding. Just kidding. Right? Because you're probably not going to see that again. But actually, these people survived. One person was killed, and the other person, not these people, but one person was killed, 8 people injured that replaced them on the same platform when lightning struck 5 minutes later. You'd think it would be instantaneous, but it was still 5 minutes. They ran down the mountain to safety. That's the best thing you can do, is get lower and run. Avoid trees, right? Because you're the tallest object, or it's the tallest object, and you're very close to them. You can get a side flash. Now, lightning goes both upward and downward from the cloud. And see, here's an upward streamer. You see that right here? From the top of the tree going upward. And here's a power line over here with lightning. It's hard to see, but going upward from the top of the power line. But where it makes the main connection to the main bolt, that's coming downward from the cloud. That's the real dangerous one. You ever hear you should crouch down, make yourself as small a target as possible? We take that back. Okay, just like the Red Cross and the Weather Service took back having candles, for example, during a hurricane. Causes fires, it's not safe. And this is really not the thing to do either, because what happens if lightning, you think lightning coming from 40,000 feet in the atmosphere is going to make a difference whether it's 39,999 feet because you're crouching? I don't think so. So the main point is, if you hear thunder, go indoors. When thunder roars, go indoors. We have that saying. If you can hear it, fear it. If you can see it, flee it. All kinds of things like that. Okay? When thunder roars, go indoors. There is no safe place outside. How about crouching down like that? That's a tornado safety rule. But in this case, this is not right because the soil acts as a conductor. The current continues in the ground. And again, crouching down and being in contact with the ground is not safe. You don't want to be along metal fences because unfortunately that's not safe. And that's what can happen. I had to give this presentation at lunchtime at a steakhouse. It was really, really up in north of Boston. Anyway, 1 out of 8 lightning strikes occurs outside the rain area. This is where most people seek shelter when it's pouring, right? But it's the bolt from the blue. Literally 1 out of every 8 strikes is outside the rain and you don't expect it. That's where people get really injured the most. Here's a great example from Duxbury, one of our weather spotters taking a picture. Here's the heavy rain and there's the lightning outside of the rain area. Maybe not the sharpest tool in the shed, let's just say, right? You see anything not too bright here? Maybe, whoops, sorry, just out for a little jog. You know, now these are just fractions of a second apart from a video. And you can see that lightning struck very close to this pole that he was just jogging by 2 seconds, fraction of a second earlier. Not safe. How about those macho baseball and soccer coaches? I used to be one of them. Say, okay, the rain has stopped, so let's get out there and play ball, right? But now you know that Mr. Field says we should wait another 30 minutes until that storm has safely passed, because it's still dangerous. If you can hear it, you're close enough to be struck. Again, if thunder roars, go indoors. It's not just baseball. How about football? This was actually, ever heard of Michael Vick? This was his team, the Virginia Tech Hokies, right at the opening kickoff in 2000, with, I don't know, 60,000 people in the stadium. Imagine if this was the old Foxborough Stadium with the metal seats, right? Lightning struck 0.6 of a mile behind the stadium. Nobody was injured, miraculously. The game was canceled. But see, these little lightning arresters, they're not going to do a hill of beans, really. And you can't fit all these people inside the concourse. You have to be weather aware. You have to move to a place of safety before lightning strikes. So what does the Weather Service consider severe? We've been talking about severe a lot in this presentation, but we never defined it. So let's ask a question. Who wants to volunteer? That's okay. You're on film, so maybe you don't want to. Anyway, I'll just make this example up. Let's say there's 1 million lightning strikes per second, burns your house down to the ground, kills your neighbor and the dog. And you like the dog. Is that is that a severe thunderstorm? And the answer is no. No? It's pretty severe to the people it strikes. But the question is, what do we consider severe? And why the heck not? Lightning is one of the biggest killers nationwide. But the reason is that what is it that causes the thunder? It's the lightning heating it up to 50,000 degrees, right? And when you heat the atmosphere to 50,000 degrees, it causes a boom. That's thunder. So if lightning was a criteria for a severe thunderstorm warning, we'd have to warn for every thunderstorm. Then nobody would believe us when the kind that have the tornadoes come by, or the structural things with large hail damaging winds. We can't warn for every thunderstorm. Now, we can issue a special weather statement that scrolls on the screen red on the Weather Channel on the National Weather Service in Norton. There's a lot of lightning strikes out there, but it won't cause us to issue a severe thunderstorm warning, because lightning, by our definition, is not severe. Okay? So who wants to volunteer for the next question? Let's say there's 500 inches of rain, okay, in an hour, in a half hour, from a thunderstorm. All of southern New England is floating away. Will that cause us to issue a severe thunderstorm warning?
No.
Why? Because I asked tricky questions? Rain, yes, it's rain. Heavy rain to us will cause us to issue a flash flood warning pronto. It'll keep our service hydrologist busy for the rest of her career. But rain is not a criteria either. It'll cause us to issue a flash flood warning. But how many times do you hear on the radio severe thunderstorms or causing flooding on Storrow Drive, stuff like that, okay, or Morrissey Boulevard, wherever it is. But to us, that's a thunderstorm with heavy rain and flash flooding, not a severe thunderstorm. So you know what it's not now, but what is it? Winds greater than 58 miles an hour. That's 50 knots. A knot is a nautical mile per hour. You multiply by 1.15 to get statute miles per hour, 58 miles an hour. Hail that's greater than an inch in diameter, that's the size of a quarter or larger. And of course, a tornado and lots of damage, that would be severe as well. So that's what we consider. So now let's talk about a watch and a warning. Severe thunderstorm, which is worse, a watch or a warning? A warning, right? Because if your mother says, I'm warning you, that's really bad, right? Okay. But a lot of people get that confused because, like, watch out could also be something you're thinking about. A watch means that it's possible over a large portion of the area. The Storm Prediction Center in Norman, Oklahoma issues watches over large parts of Massachusetts, Rhode Island, Northeast Connecticut, and go about your normal business, but keep a close eye to the sky because thunderstorms could form quickly and they could become severe. Okay, but a warning means that we've actually seen it on the radar or one of our spotters has observed it. So it's imminent or actually occurring. So it's definitely going to happen. So large hail damaging winds. Let's talk about the hail first of all. Hail forms in a thunderstorm when the updraft, every thunderstorm has an updraft. It rises up, it cools above the freezing level and freezes into a hailstone, a big glob of ice. But then it starts to fall, but then another updraft brings it up and it gets bigger. It refreezes and then it melts again as it comes back down, and it goes back up again and gets even bigger. If you cut a hailstone in half, see all these little concentric circles of like tree rings every time it's frozen and refrozen on its way up. Okay, so how strong that updraft is determines how big that hailstone is going to get. So we know that a golf ball size hailstone, for example, 1 3/4 inches, has a 56 mile an hour updraft that sustains it until it's big enough to fall down through that updraft. And you get up to 2 3/4 inches, that's the size of a baseball. If you get 3 inches, that's a 100 mile an hour updraft. The air's coming together and going up faster than Pedro Martinez's fastball used to be.
Yeah.
Okay, used to be. Okay, that's an incredibly organized storm. Okay, so anything that's golf ball size hail or larger is capable, the updraft is strong enough that you have to start thinking about a possibility of a tornado, even if there is no tornado warning. So would this be severe in terms of hail size? What do you think? This is 4 inches in diameter, yes? 1 inch is our criteria, just 1 inch. So this would be pretty severe. 1 inch is what we consider severe. And we've got lots of people sending us pictures now with the internet and cell phones. We tell our spotters never to report marble size hail. Why? Lots of different sized marbles, right? Put things in terms of inches. Put things in terms of inches or US coinage, things like that. Hail can do a lot of damage. So we tell people to report any hail, though. But our weather spotters, we actually had someone report sand size hail. So we have a little minimum criteria of maybe bigger than sand size. It's got to be like pea size or something. But it's very important that our spotters or anyone report it to the National Weather Service close to when it's happening, because we can take that report, say, oh, they're getting pea size over there, they must be getting golf ball over there. Okay, so your report might seem insignificant, but it can really help us out. And the 58 mile an hour winds is what we consider severe. On the wind side, that's enough to knock down whole trees. We ask our spotters to start reporting when it's about 40 miles an hour. So strong winds can take the form of straight line winds, which we call downbursts. You ever hear of a microburst and a downburst?
We had one.
Yes, you did, and I'm going to show you it.
No.
That was in 1996. So downburst is the generic term, but a narrow downburst with less than 2.5 miles in width is considered a microburst, and if it's greater than 2.5 miles, it's a macroburst. But a downburst is the generic term. It can cause a lot of damage. Here's what a microburst did to a Doppler radar tower. Downbursts can form from evaporation from just a regular shower. Doesn't even have to be a thunderstorm. Evaporation is a cooling process. So if the temperature is 90 but the dew point is only 60, a very dry atmosphere, when it evaporates, it gets colder than the surrounding air and can accelerate downward because cold air is more dense than warm air. It's like if you take a shower and your skin feels cold because it's evaporating when you get out of there. Same idea. Okay, very dangerous to fly through these. Pilots need to avoid any kind of evaporation and downburst potential. But another way that it can form also is just strong winds that get advected down to the ground. If you have really strong winds aloft one day and a thunderstorm comes and just drags it down to the ground, basically. This is a picture of a downburst, and then what comes out at the bottom there, races out, is very dangerous. The highest one ever measured was 175 miles an hour out at Morehead City, North Carolina. And now that's going to cause a roaring sound, right? Or it sounded like a freight train. A lot of people confuse it with a tornado because of that. But wind is wind, and it makes a lot of noise. So twisted trees and twisted road signs don't necessarily mean it was a tornado. It could be the center of gravity of that big oak tree could have been leaning over to begin with, and then it gets twisted. Or that's the initial angle of attack of those downburst winds. So here in Brockton, Whitman, Abington, in May 21st of 1996, we had 104 miles an hour measured right here in Whitman, I believe it was. And coincidentally, another 104 mile an hour gust at the College of the Holy Cross in Worcester in 1998, just 2 years later. As viewed from the air, what comes down spreads out with distance. That's divergent damage. And that's evidence of a microburst or a downburst, because what comes down spreads out. As opposed to a tornado. Tornado is low pressure, so everything blows in toward it. My simplest example, we show this in schools a lot, not sure how scientific, but if you squeeze a tube of toothpaste, right, and put high pressure on it, where's it going to go? Assuming the cap is off, right? Away from the high pressure, toward low pressure. So things like to go toward low pressure. And so the air comes in toward the low pressure, and there's also rotation. So in that case, you'd see one coherent track with everything blowing in toward the center. Now, sometimes you see circular tracks on the field, then you know it was a tornado. So now let's come back to here. In 1996, the Brockton, Whitman, Abington downburst, big pine trees blown down in front of this person's house on Route 27. 60 people were injured, $4 million worth of damage, and 104 mile an hour wind gusts. We went out, there's still lightning in the area, came and surveyed this damage. And the next day I got to fly in the WBZ helicopter. I said, never again. Nothing wrong with the pilot. Just I kept thinking, what happens if he has a heart attack and I don't know how to fly this thing? It was just like, you know. But anyway, there's those same two trees in front of that house. Didn't look that bad from the air. It looked a lot worse at the ground. There's a tree blown down in the same direction. Way up here, you can see another one blown down in the same direction. But most trees are standing. This is typical New England damage. But the pilot said he could find his way home without a compass because of the way that the trees were all blown down in the same direction. Now, this forest in Abington, the same side of each tree was sheared off. You'd think if it was a tornado, there'd be some on this side and some on that side. That's evidence of straight line wind damage or a downburst or a microburst. But this got us going. The leaves were plastered all over the front of the house and all over the back of the house. So if it's straight line winds, how'd it get around the whole house? But there wasn't any damage to any windows. Not even a shingle missing. You'd think if a tornado hit it, something would be wrong with the house other than leaves being on it. And so that's consistent with a downburst bouncing off the ground, creating these various swirls and eddies at 104 miles an hour. There's another shot of two trees lying down in the same direction. And they took me on a nice tour afterwards. Very nice tour. And maybe we'll get to say this in a few days again. Yeah. Anyway. Now, we have drones nowadays and things like that, which are really helping us be able to see things a lot better than just a ground survey. This was damage on Mount Tom out in the Holyoke area. But as seen on radar, this gets a little complicated, but see a big cell over that area. But when we look out to the west from Taunton, or from, the radar is still in Taunton, our office is in Norton on the other side of the radar, we have these greens which indicate the air coming toward Taunton, and these pinks and yellows, the air going away from Taunton. So in this case, they're coming together like that, But remember, the beam is up at around 8, 9, 10,000 feet at that location. So if the air is coming together, where's it going to go? Well, downward mostly, a little bit upward. That's indication of a downburst as viewed by radar. Now if we switch gears and take a look at tornadoes, a tornado is a violently rotating column of air in contact with the ground. If it's not in contact with the ground, what's it called? If it's just up in the air? A funnel cloud? When the funnel cloud touches the ground, it's a tornado. But if it's just up in the air, it's a funnel cloud. So the enhanced Fujita scale is how we rank these things from 0 to 5. And EF1 is from 86 to 109 miles an hour. EF3, for example, can knock down roofs, trains overturned. And EF5 doesn't matter where you are. The only people that survived the EF5 tornado in Wichita Falls, Texas in 1979 here had sought shelter in a bank vault. So here's the enhanced Fujita scale. EF0 is small enough that they didn't put a picture there. And EF2 can knock the roof off an apartment complex. And EF3, the side walls. And an EF5 doesn't matter where you are. Even in your basement is not safe. Locally, we had the Worcester Tornado, Great Barrington Tornado. Some of these we've already showed you in the beginning. The granddaddy of them all was the Worcester Tornado in 1953. It was on the ground for 46 miles and 1 hour and 24 minutes. 94 people killed. Started out by the Quabbin Reservoir in Petersham, and actually a second tornado was spawned after it. There's a picture of the Worcester Tornado. Now that's a Midwest-style tornado. It was officially an F4, or EF4 as they reclassified it, but 10 football fields wide. Think about that. 26 people killed on these 3 streets alone in the Burncoat section of Worcester. More Worcester tornado damage. Senator John F. Kennedy surveying the damage afterward. Worcester College, the Assumption College in Worcester, big brick building destroyed. Now in Great Barrington in 1995, we had another tornado with only a severe thunderstorm watch warning in effect. This is the Great Barrington Fairgrounds. Some white corrugated plastic roofing material and a racing ticket were found 45 miles away in Belchertown. That's one clue that it was a tornado. In the Worcester tornado, frozen mattresses were found that had been lifted up from Worcester and found in Boston Harbor. That's incredible. 70,000 foot tall storm. Lent a new meaning to the word mobile station, right? But you can tell that it was not an EF5 tornado because there was one pump left standing and a lot of the roof, actually. And the damage cost an arm and a leg. Just kidding. Anyway, that's really funny now, though. 172. Well, anyway, these are forecasters from the Albany Forecast Office, which covers Berkshire County. We cover everything east of Berkshire County from the Norton office. Standing in front of this truck, which smashed into the Big Y supermarket, creating that new entryway. A terrible sight at the cemetery. And just getting in there with the media circus the next day, and I don't know if this is the Secret Service taking a picture of me taking a picture. I don't know. Anyway, this is your former Federal Emergency Management Agency Director, Louis Elisa, working hand in hand with your Massachusetts Emergency Management Agency Director, former Director David Rodham. Maybe not the best view of the Western Massachusetts Emergency Management Agency Director, but it's okay. He knows that I do this, so. Now this is my favorite picture. This is the back of the mobile station, okay? And there's the mountain that this serious tornado smashed into. When it got on the other side, 3 people were killed. 2 teachers, or a teacher and then 2 students, or 2 teachers and 1 student. The width of the damage in the mountain was 300 to 400 yards wide. Now, I know that when I walked from one end of the mobile station to the other, it wasn't 300 yards. It was, I don't know, 50 feet, 80 feet, something like that. Take a look at this metal pole right here, which used to say mobile on it, blowing in toward the center. See that? Now look on the other side, this metal pole, which used to say mobile on it, blowing in toward the center also. Both of these are blowing in toward the center. Why? Low pressure. In the tornado, everything blows in toward low pressure. There's clear evidence that was a tornado, and it went right through the heart of the mobile station, but the width of the mobile station is much less than the width of the mountain. That's how a small scale rotation, that's how one house can be left standing and the one right next to it totally destroyed. It's a small scale rotation within the main tornado. This 4x4 was driven right through the car, ended up right there, peeled back the foam rubber seat cushion of the passenger side, which slowed it down. There's the steering wheel, slowed it down just enough so that the driver, who escaped with a serious hip injury, wasn't perforated. This is Massachusetts, not Kansas. Almost the fourth fatality. Now, the milk and the eggs were untouched. I don't know if that was set up the next day. I don't know. On June 1st, this was really an awful sight. This is what we call a hook echo. Heavy rain wrapping around a tornado, and this little ball at the end of the hook echo is actually what we call a debris ball, which is trees and buildings lofted way into the air by the tornado. Now this is the reflectivity, how hard it's raining. Taunton radar way out here looking to the west. And here's the velocity. The Doppler radar tells you how those raindrops are moving within the storm. And so you see all these light blues racing toward Taunton at 75 knots, which is like, what, 85 miles an hour, something like that. Immediately adjacent to these pink shades off the other end of the scale. Here's the blue on one end, pink on the other end at 68 knots, going the other direction. So if this is coming toward, that's going away. Big circulation right at that same spot. And that's over 150 miles an hour, as seen by our radar. So as viewed from the satellite in space, you can see the scarring of the land all the way out to Charlton. 38 miles on the ground, not 46, but 38. And that was pretty impressive. By the way, if we back up there, nobody ever talks about it, but if this hadn't been there, this one was organizing, it would have been the Grafton tornado. Anyway, we'll move quickly through this because we want to do hurricanes too pretty quickly here. So anyway, there's two tornadoes at the same time on the ground in Berkshire County, 1997, the Cheshire Fairgrounds in Swanzey, New Hampshire. Now you can tell this was an EF1 tornado because it's made out of wood and aluminum, not a big brick building like the Worcester Tornado. A recycling center in Greenfield, New Hampshire. This was rated 2. A Great Brook Middle School in Antrim, New Hampshire. This was a combination of a tornado and a microburst in Northampton, Massachusetts. Little tiny tornado went through this cornfield, but it managed to drag the trailers in circular paths on the ground. And this was the Princeton, the Father's Day tornado in 2001. Remember, it made up for not having had one in a while. We were concerned with this heavy rain coming from the remnants of Tropical Storm Allison that did a lot of damage down in Texas. But anytime you have a decaying tropical system, it can lead to, look what we have here, a hook echo again. And on radar, all the blues rushing toward Taunton, the reds moving away from Taunton, 100-mile-an-hour circulation right there, and did some damage in Princeton. This time, my boss got to fly in the helicopter. And look what you see, one coherent track, right? But most of the trees standing, most people in Princeton had no idea their town had been hit by a tornado. And look where it ended, right there, right before this, all these $400,000 homes. It ended right there. Now, there's an interesting story here, too, is that it did impact 2 homes, and one of them had people that were Skywarn trained from the National Weather Service Weather Spotter Program. They waited their whole life to report this, and the phone line was dead. So there's a good case for amateur radio, right? Because you could get through to us on 2-meter amateur radio band. Whoops. So you know how you can hear the roar of a tornado? You can hear the roar of a tornado a mile away? Well, with those big ears, the Preparedness Cat could hear the roar 10 miles away, right? And she was listening and heard that a tornado watch was in effect. They were listening for later statements and further developments on NOAA Weather Radio. Very precocious cat. And she heard that then a tornado warning was in effect. So she told all of her relatives that the storm was coming, right? They all knew the storm was coming. Yep. Even told the dog. You can do a lot with greeting cards. Anyway, I told you the jokes are corny. Anyway, soon the whole household knew the tornado was coming. Everyone in the whole town was rushing their loved ones to safety. So Preparedness Cat decided to take protective action, put on the helmet. The dog said, "Come on, let's get down to the basement." Okay. Sure enough, the tornado came. Everything was blown this way and that away. The duck was blown right out of the pond, almost hit the tree. The cat was blown right through the fence. Okay, there's any animal lovers. I'm an animal lover too. But I have to put this disclaimer in here now that no animals were injured in the making of this presentation. Only a joke. Everyone lived happily ever after and lived to tell just how big that tornado was. You see, I think it was this big. Anyway. The debate went on for centuries. I think it was this big. Anyway. You don't want to be in your car. You don't want to be in a mobile home. Mobile homes are attracted to tornadoes. The best place is in your storm cellar. What? You don't have a storm cellar? Or in your basement. What? I don't have a basement actually either here. Then the best place is in the lowest floor in the interior of the building. Put as many walls between you and the storm as possible. If you're outside, that's not a good lightning safety rule, but it is a good tornado safety rule. Get in a ditch, cover your head, and hope. In schools, the worst place to put children, and adults for that matter, is in the auditorium, the gymnasium, the cafeteria, the all-purpose room. Why? Because of these big, wide-span roofs that can easily collapse. And so the best place is in the interior hallway, away from windows, or if you don't have time, underneath your desk in the classroom. You ever hear you should open up your windows to equalize the air pressure? Low pressure outside, they say this for hurricanes too. Low pressure outside, high pressure in your house. Everything likes to blow toward low pressure, so my windows are going to explode out toward the tornado, right? So I better open up my window to equalize that air pressure. No. There's the tornado, and there's your house with the window open. No, tornado doesn't care whether your window's open or not. So more people trying to remember rules. The thing is get to a safe place. You have to be proactive, not reactive. You have to know what the forecast is. Now here's 2 pool managers who know that this is a place that gets a lot of lightning, so much so that they have a lightning detector right at the pool. But lightning's striking and they're doing absolutely nothing to protect anybody in the pool. Okay, remember, pools were number 3 or 4 on the list. You don't want to be where water conducts electricity. What do you think? Should we cancel the game? I don't know. I don't know. And then this is definitely, whoops, where are we? Oh, I skipped that slide. Well, forget that. Anyway, we did the cats, so we got to do the dogs, right? So this is the Dodger Dog wind scale. D0 is a calm wind. The eyes are open, the ears are perky. Good dog, born in 2005, just a little shaken up. is a gentle breeze, 10 miles an hour, D1. Now this is a D2, 25 miles an hour. The eyes are squinting and the hair is matted along the top of the head. This is a D3, 40 miles an hour. The eyes are shut and the mouth is wide open. And we want to see if Dodger Dog withstand the 100 mile an hour wind test. Like I said, he's alive, just a little shaken up. Different dog. No animals were injured in the making of this presentation. Okay, that was it for that. But now, what I'd like to show you, since we're still on the severe weather topic, let's go to a video. This is my favorite video, one of my favorites of all time. But I have to tell you what it's about. This is in Florida at halftime during a football game, a high school football game. The marching band is out there. The band director is over here. The opposite team is right underneath this pole and these trees. And there are several clues that lightning is going to strike. You have to listen closely, don't talk. And I think we can turn the volume up here a little bit, and hopefully you'll hear and see some of the clues. Let's see. But the important thing to watch is the crowd's reaction and the what the band does. Okay? All right. If you heard that, there was a little roar of thunder in the background, very faint. Another little bit of thunder, you hear that? When thunder roars, go indoors. All right, is anybody going anywhere? No. There was a little flash in the background. More thunder. That's 3 clues already. I think I missed it because I was talking, but there was a flash in the background. See that? Cloud to ground lightning there. The band stopped. Why? Because it's the end of the song. Everybody is still congregated under this tree. They're still marching. A couple people leaving. For some unknown reason, they decided to move away from this tree. That was a smart thing because lightning struck that tree. For some unknown reason, they decided to move about 3 seconds before that, and 20 people would have been killed. Now the football players are running inside, but not the musicians. He's still conducting. Unbelievable. The point here is adults can be very stupid. When thunder roars, go indoors. That was incredibly lucky that 20 people were not killed, amazingly. What I could show you is the next picture that shows we had thunder at 8 seconds. There was more thunder at 25 seconds and more thunder at 38 seconds into that video. That's 3 clues right there. Then we had a cloud to ground lightning strike. That's the 4th clue. With thunder after that, the 5th clue. And then the tree was struck.
Oh.
And it was on fire. But what did the paper say? It was a surprise. Came with no warning. Actually, there was a 1.5 minutes worth of warning. And maybe more if they had read the forecast, I don't know. Anyway, I just wanted to show you that. So, we'll have to run through the next one very quickly, but if you can stay a little bit longer, and we can get through the whole thing. But hurricanes are actually the thing that keep me up at night the most here in southern New England, because they can cause the most damage across the entire area, and people have no idea what can happen. And so I'll try to get through this as fast as possible. But people of my generation remember Bob in 1991, Gloria in 1985. Anybody remember the 38 hurricane? No? See? How about 54, Hurricane Carol? One person. So, I like to say we have kind of a warped sense of reality. You know what, I'm going to skip, well, no, I won't. Let's go to this. So when was the last hurricane that hit southern New England? It was Hurricane Bob in 1991 that actually hit southern New England. Sandy doesn't count, that was a side swipe, and technically it wasn't a hurricane as it moved into New Jersey. Irene was a tropical storm. So we've had many close calls, but the last hurricane was 1991. The last major hurricane, and by that we mean a Category 3 on the Saffir-Simpson scale that goes from 0 to 5, and that was 1954 with Hurricane Carol. And so it's been, what, 64 years since we've had a major hurricane. But let's talk about a tropical storm, because they can be bad. They can be bad too. So Tropical Storm Irene caused. Now this slide is for Connecticut, provided by the Connecticut Emergency Management Department, but you get the idea. Comparing that with a major hurricane, Irene downed 1 to 2% of Connecticut's trees. But in a major hurricane, 70 to 80% of the trees would be down. So think about that as you go home tonight, where there'd only be 1 out of every 5 trees left standing. Okay, Irene had 800,000 power outages. It took 9 days to restore the power. In a major hurricane, we're talking about months to restore power. $200 million in damages versus tens of billions of dollars in damages. These are values of what the 1938 hurricane would have done in today's dollars. $54 billion worth of damages in just Connecticut alone. There'd be 364,000 displaced individuals. That's 144,000 households with roughly 3 people in each household. Now think about this. The day after a major hurricane, Category 3, only 3% of police, fire, and ambulance services will be functioning. Only 3%. Don't expect to get rescued. And how about a month after a hurricane? Only 40% of hospitals would still be functioning. 60% of hospitals would not be functioning a month after a major hurricane. Bad time to have a heart attack or to need surgery. Imagine all the trash generated in Connecticut for the whole year. That's how much debris had to be cleaned up. So we've had 4 Category 2 and 3 hurricanes in a 16-year period last century, running from the 1938 hurricane, which was a Category 3, major hurricane, 1944, Carol in 53, Edna was a 2, but still very strong, also in 1954. So they all happened in that 16-year period, and we haven't had any in 64 years. If you look at the National Hurricane Center website, it gives you return frequency. The average return period for a hurricane of any kind is 13 to 17 years along our coast. And it's been what? Since 1991, that's 27 years? 27 years we're due for a hurricane. And the average return period for a major hurricane is 58 to 62 years, and it's been 64. So we're right in that time frame. Can't say it'll be next year, the year after, but sometime in the next 10, 20 years, we're in that time frame where we'll get a major hurricane. So let's talk about the hurricane. I'll go pretty fast here. This is the eye of Hurricane Elena in 1985, as seen from the space shuttle. No hurricane talk is complete without thanking the Air Force for flying into these things, as well as the NOAA reconnaissance flights. Our New England hurricanes come from two source regions. One is the Cape Verde Islands off of Africa, okay? And those get really big because they take days to wander across the Atlantic, get bigger and bigger, nothing interfering with them, no land areas. They can be like Hugo, Andrew, Hurricane Mitch. Hurricane Allen in 1980 took up the entire Gulf of Mexico. But at least we know they're coming. That's all that the media is going to be talking about for days and days and days. Okay? The other source region for us is in the Bahamas, off of Florida here. And those storms tend to be smaller. They sort of feel the coastline, and they're smaller, but don't confuse how small they are with how much damage they can do. And the thing about them is they can fly up the coast in no time. Hurricane Bob was nothing more than a cluster of thunderstorms on a Friday afternoon when all the emergency managers went home for the weekend. And by Monday morning, it was a major hurricane. It was a major hurricane on Saturday, Category 3. And by Monday, it hit weekend, but it was in for breakfast and out for dinner, like most New England hurricanes. Ours mostly come in August and September. We've never had a hurricane in July that actually hit New England. It takes that long for the waters to warm up south of New England to sustain them this far north. And they come in cycles every 20 to 30 years. Not as many, even though a big one in 38, but not as many in the 20s, 30s, and early 40s. A lot of them in the 50s, 60s, and early 70s. Not as many in the 80s and 90s. We had a lot more in the 2000s and into 2010. We even went into the Greek alphabet in 1 year. So I guarantee, though, that by the 2030s or so, we'll be heading back toward less number of storms. But our mantra is, it only takes one. Doesn't matter how many storms there are. In 1995, there were only 7 named storms, but the very first one was Andrew. Okay, or 92, I think it was. Anyway. So an upper level trough comes down from the Great Lakes, down to the Gulf of Mexico, and up the Atlantic coast. That's where we get our things from. If a hurricane is coming across the Atlantic, gets caught up in that trough, it can sling right up the coast. But it's really difficult to get it in that location. A little bit to the west, and it'll go up the Appalachians. A little bit to the east, it'll recurve out to sea and hit Bermuda or points eastward. But if you do get in a trough like this, and it's very amplified, it doesn't move very fast. So another storm comes by and gets sucked back up. That's what happened in 54. We had Carol and Edna within the same week of each other. And in 55, we had Connie and Diane, one right after the other. So we're just going to keep remembering a few of these tracks. The 1938 hurricane is this big red line, went up through western Massachusetts and actually hooked a left into Ontario. Diane moved into the mid-Atlantic and then paralleled the New England coast as a tropical storm on its way out. And Carol is this magenta line that moved through central part of New England. So those are the three I want to pay attention to. In the latter half of last century, most of the storms affected southeastern Massachusetts, but they were weaker. Gloria was a 5 at one point, but it weakened to a 1 when it hit New England, and it came at low tide. Floyd was a tropical storm. Bertha was a tropical storm. When they hit us, Bob was a weak Category 2 hurricane. So there's a few things we want you to remember. Our storms accelerate up the coast. The name of this talk is The Realities of New England Hurricanes. And why New England hurricanes? Our storms are entirely different than the kind that you read about in the textbook, or that hit Florida, for example. You know, in the textbook, a hurricane is strong winds and the rain blows from this direction. Then the eye comes out and it's sunny, right, and calm. And everybody goes out and plays tennis, but they shouldn't have, because the other half of the storm comes by, the rain and wind is just as bad. And our storms are not like anything like that. The reason is they accelerate up the coast. And all the important impacts from them are way out ahead of the storm. So if you're waiting for the eye to come ashore, that's pretty much the end of the storm. You're going to be too late. But you do have to know where you are with respect to the track of the eye, because the high winds are east of the track, and that's what causes the storm surge to come up. The flooding rains are along and west of the track. We had a research student that came by and plotted out the locations of where the storms were, in this case, 5 days before landfall or near landfall here in New England. And it was in the Bahamas. 4 days before, it was in the Bahamas. 3 days before, it was in the Bahamas. 2 days before, it's starting to move and getting into that little corridor there east of South Carolina. We have a rule of thumb that it has to get to 72 west in order for us to have a chance of getting hit. Otherwise, it recurves out to sea. 1 day before landfall, it's off the Cape Hatteras area, and then it hits us. So therefore, anything with a name in the Bahamas is our business. That's where we have to really start paying attention and acting on it. So if there's one thing I want you to remember from this presentation is this slide. The 3 rules of thumb for New England hurricanes. The first rule is forget about when the eye is going to make landfall. But I just described why. Everything accelerates up the coast, you're going to be too late. Excuse me 1 second. Too much talking. That's better. The second rule of thumb, though, is you have to know where you are with respect to the track of the eye, because north and west of the track, that's where the flooding rains are going to be. South and east of the track, the strong winds and the storm surge. And if you want to know why that works, low pressure has counterclockwise winds in the northern hemisphere. And so on the east side of the storm, everything has an additive effect, right? It's moving northward, and the winds are going from south to north. So that's where the strongest winds are. So the third rule of thumb demonstrates that. You want to figure out what the highest wind gust is at your house. You can, if you're east of the track of the storm, you can take the maximum sustained winds, case of Hurricane Bob, 95 miles an hour. Moving north at 30 miles an hour, you can take the 95 and the 30, and what do you get? 125 mile an hour wind gusts on Cape Cod and the islands. West of the track, 95 minus 30. It was like 60 or 70 miles an hour in western Rhode Island. Okay, so to show you how that works also, in the 1938 hurricane, maximum sustained winds 125 miles an hour, moving north at 60 miles an hour. So what was the highest wind gust at the top of Blue Hill? 186 miles an hour. I know you got 185, but that's close enough. But anyway, so that really works. It's kind of like being on a people mover at the airport. If you're, you're walking in this direction and it's moving in that direction, you get there really fast. Whereas, let's see if I can do it. You're walking in this direction, but it's still taking you. You get there, but not as fast. Is that right? Here's Hurricane Bob off the North Carolina coast, radar picture. Okay? Flooding rains north and west of the center. Sunshine south and east of the center. But 14 hours in advance, there's already squalls shutting down coastal roadways in Rhode Island. 14 hours in advance of the eye. And what happens when Hurricane Bob meets the colder shelf waters off of New England? It kind of lost its eye and opened up and kind of transitioned into a typical New Englandish nor'easterish appearance with flooding rains in Foster, Gloucester, Rhode Island, sunshine, and 125 mile an hour winds on Cape Cod. So we're going to talk about the wind, the rain, and the storm surge. Can also be a little tornadoes from the storm. We'll go pretty fast here. Hurricane Bob, again, took this track up, just to the west of the Cape Cod Canal. Less than a half an inch of rain fell during the entire hurricane on Cape Cod. Isn't that hard to believe? 6-7 inches of flooding rains in Foster, Gloucester, Rhode Island. But when Mother Nature wants to dump on you in a big way, she can. Tropical Storm Connie came by in 1995, and we had been in a drought, so we only had 7 or 8 inches of rain from Connie. Just kind of saturated the ground, but didn't really cause any flooding. But less than a week later, Diane came by. Remember, it moved into the mid-Atlantic as a hurricane and then paralleled the coast of southern New England as a tropical storm. So which side is New England on? The whole of New England is on the rainy north and west side of the storm, right? So here's 1 foot of rain in this contour here. And out in Westfield, Massachusetts, they had 18.15 inches of rain in 24 hours. That's more than half their annual rainfall in one day. So that caused a lot of flooding. By the way, here's an emergency management problem that you would not really think about, right? See, the water receded, and the cows are still up on top of the roof. Something to think about. Inland water flooding. This is Route 44 in Putnam, Connecticut. You can still drive through there today. The Quinnebog River runs right underneath it. Keep your eye on this building and the lamppost kind of going up to the 3rd floor of the building there. That's before the flood, and this is during the flood. Now that's a flash flood, the likes of which we haven't seen in southern New England in 6 decades. Well, the Corps of Engineers, they built a structure upstream here, so it's not going to happen at that place anymore, but lots of places where this could happen. There's the Blackstone River in Woonsocket, Rhode Island, completely out of its banks. The Connecticut River in Hartford, also some tidal influence there. And Winchendon and Miller's River in Winchendon, Massachusetts, all flooded. And Tropical Storm Irene, there were houses floating downstream. So that's the rain part of tropical systems. Now let's talk about the wind. This is what causes rotating hurricane winds in southern New England. See the different TV trucks going in a counterclockwise. Channel 4, 5, 7. It works in Rhode Island, just say 10, 12. Anyway. Just kidding. Anyway, tropical system definitions. So a tropical disturbance turns into a tropical depression that's low pressure with 38 mile an hour sustained winds or less. When it hits 39, it becomes named as a tropical storm, and when it hits 74, it's a hurricane, category 1 hurricane, and on up from there. It goes all the way up to greater than 155 miles an hour as a category 5 hurricane, but the destructive potential of wind increases by the square of the wind speed. So it's exponential as you get higher up how much damage it can cause. And so here's the energy score. As you can see, relatively speaking, it becomes like dramatically higher as you go up, the kinetic energy of the wind. This is a picture of the Doppler weather radar in San Juan, Puerto Rico after Hurricane Maria. So let's go back to Hurricane Bob. There's a tree on a house during Bob. There was an anemometer behind this house that measured 40 miles an hour. Remember, a tropical storm is 39. This is the weakest of tropical storms. Gust is 60, but we count the sustained wind, 40. Okay, so the wet soil conditions, though, can cause still a lot of damage. Now we got gusts to hurricane force, but still a tropical storm at this location during Gloria. You don't want to be doing that, right? Stay away from electrical wires. During Hurricane Andrew, 5 people were killed after Andrew from trying to be good Samaritans. You don't know if there's power connected to those wires. Even if people have a generator, can be hooked up improperly. So this guy has the right idea, like what is he doing out there? Anyway, and here's another shot of hurricane force winds, gusts, but still a tropical storm. But now this is Category 3 Hurricane Carol at Bonnet Shores, Rhode Island, where your whole house is wiped apart, okay? And remember what I just said in the tornado section, the safest place is the lowest floor in the interior of the building. That's the only room that wasn't damaged. Go to the middle, the lowest floor, put as many walls between you and the storm as possible. They used to evacuate people into large, tall buildings. That was an evacuation plan. But this was tornado damage in Fort Worth, Texas, but you can see that's not safe. At the same speeds as a hurricane, and a hurricane will last a lot longer than a tornado. This went through for half an hour. Imagine those winds for a couple hours at a time. Here's the forest in Falmouth after Bob in 1991. Martha's Vineyard State Forest a few years later trying to recover. But in 1938 hurricane, 238 million trees were down in Connecticut alone. I don't know how they measured it, but that's what they say. And underneath that today is all kinds of buildings, and so much more dangerous. This was the 1938 hurricane. Remember, it was moving at 60 miles an hour, so no time for it to weaken. So all the way up through Rhode Island, New Hampshire, we had all those same wind speeds up around 185 miles an hour. This is a big brick factory. Looks just like the Worcester Tornado, right? The Assumption College picture of a brick building, totally destroyed the top layer of that. And then here's all the way into Keene, New Hampshire. Trees through homes. This is big brick building in Sargent Motors in Keene, New Hampshire. And this is the Peterborough Transcript newspaper building, flooded out and on fire.
I just wanted to let you know we'll be closing in just a few minutes.
Okay, we're going to hurry as soon as we can. So, very fast. Hurricane Andrew is Category 4. That's what it did to the house. That's the rest of the house. This is going to be the fastest presentation you ever saw. Okay. Coral Gables, Florida. This was the National Hurricane Center parking lot after Andrew. Hurricane clips and straps can make your house stronger, and you can tell which house had them and which house didn't. They really do work. Okay. You already saw the dog, so we're going to skip that one. It works for hurricanes and tornadoes. Anyway, tornadoes can form in the northeast quadrant of the storm. There's the hurricane. There's the tornadoes. You already saw what happened when we had a decaying hurricane. Caused the tornado. And the storm surge. Very important. People who are living near the coast. Musquamacut wiped that. 50 people dead. Grew out to 250 in the 1938 hurricane. There's Musquamacut before and after. The storm surge is the rise in the water caused by the strong winds. 1 foot of it, though, is caused by the lower pressure. And so if it's 2 feet above normal, 15-foot storm surge would make a 17-foot storm tide. That doesn't count the wave action on top of it. Long story short, let's get to this. See what I'm talking about here. Here's Crescent Beach before Hurricane Carol, and there's Crescent Beach after Hurricane Carol. This house belonged there. This house belonged there. You get the idea. Okay, Hurricane Bob, 6-foot storm surge in Falmouth. Caused a lot of riprap along the coast. Here's my favorite house in Falmouth. There's Buzzards Bay. Here's the little seawall, just a joke, that protects it. And this is what it looked like during Bob, with a 6-foot storm surge. But nobody realizes that all down the street from that location, the water would be over top. The worst place is Gray Gables in Bourne. Look at how low they are. And the models show that there could be a 30-foot storm surge someday. And there's that same house, and the water being 17 feet in the worst case scenario. That's important because when Edna went by, New England is the only place where the winds turn to the northwest after the storm is gone, and that's when you get your flooding on the inner part of Cape Cod Bay. And you want to lower your mass. But the 38 hurricane, 250 boats wiped out in this one marina alone, and this house belonged over there. But your boat is not safe if you have slip ring moorings because they don't work. Sandy caused a lot of damage along the Rhode Island coast. Just take a look at how much sand was deposited. There's the doorknob. See that? That's incredible. And it unearthed these cars. And we couldn't figure out why, but in 1954, this was a project where they actually reconstructed the dunes by burying cars under there. And it took 60 years to unearth them. Anyway, let's leave it at that. Hurricanes are bad. All right. This is just a made-up scenario as to what would happen if a storm came up to us, but let's leave it there. because we do want to get out of here. But thanks for coming, and I'll be around if you have any questions. We did it.